Next, we have October silhouetted in her glorious majesty, and we're going to talk about long-run behavior of polynomials. You may have heard long-run behavior called the same thing as end behavior before. Those two terms are used interchangeably. But long-run behavior of a function is just how does the function act for infinitely large inputs in both directions? So as x goes to all the way to the left, how does the function behave? As x goes all the way to the right, how does the function behave? We call that the long-run behavior or end behavior. So let's look at a bunch of examples, and there really are a bunch. We're not going to write stuff down for every single one of them, but I want you to look for a pattern. What's the pattern with the long-run behavior? Okay, so this first one, we've got this one graphed over here. What happens to this function as we go all the way to the left and as we go all the way to the right? Well, let's zoom out and make sure, oh, yep, that's the whole function. Okay, well, what's happening? As we go to the left, what is the function value doing? As we go to the left, the function value is going down and down and down and down and down. So that's how we write it. Where's my pen? So as we go to the left, as x goes to the left, negative infinity, what does the function do? The function's going down. And it's going down as far as it possibly can. The function's going all the way down to negative infinity. What about as x goes all the way to the right? As x goes to positive infinity, as we go further and further to the right, further and further to the right, what's the function doing? Oh, it's going to the moon. The function, oh man, my green screen's really starting to get upset. The function is going off to infinity. The y values are going to positive infinity. We're going all the way up. As we go to the right, we're going infinitely up. This function is going to positive infinity. And like a little picture to represent what this is as we're going to the left, we're going down. As we're going to the right, we're going up. Straightforward enough, hopefully. Let's get some more practice. Let's look at the second one. Is this the whole function? Yeah, that looks like the whole function. Well, as we go to the left, we're going all the way down. As we go to the right, we're going infinitely far down. So this one, doesn't matter whether we're going to the left or the right, we're going down. The function is going to negative infinity. To the left, we're going all the way down. To the right, we're going all the way down. This is our answer, by the way. The picture's just to help us get there. So you could write it very similarly, or we could take a little shortcut. As x goes to positive infinity or minus infinity. The plus or minus means it doesn't matter. As x goes to positive infinity or negative infinity, the function does the same thing. The function is going all the way down to negative infinity. Okay. So we're on the lookout for patterns. We only have two things so far. Kind of hard to find a pattern. Yeah, let's keep going. Negative x. We know what this graph looks like. This is a line, negative x. So as we go to the left, what's the function value going? As we go to the left, well, we're still going getting infinitely big. We're getting infinitely high. Infinitely high, yep. And then as we go to the right, we're going infinitely down. So infinitely high to the left, infinitely down to the right. We say as x goes to negative infinity, as we go to the left, the function value goes up. As x goes all the way to the right, the function value goes down. So that's how we answer these questions. Let's be on the lookout for patterns. We're not going to write down the answers to the next few graphs. Let's look at the end behavior, at the long run behavior. X to the fourth. Okay, it's going up in both directions. It's going to positive infinity to the left and to the right. Functions going up, both sides. Well, let's look at letter E. What if we add a 4x cubed? Ooh, so now we got more stuff happening. We zoom a little bit. Now it's doing more stuff in the middle. But we're talking about long run behavior. We only care about what's happening at the ends. Well, we got stuff in the middle, but we go to the right, going all the way up. We go to the left, going all the way up. There's no difference in the long run behavior. Well, what if we add a minus 2x squared? Again, different stuff happening in the middle, but that long run behavior is the same. Well, what if we add something else? An x minus 10. Different stuff in the middle, but the long run behavior is all the same. So where are we going with this? What is really what's determining that long run behavior? The long run behavior is determined by the leading term. Okay? So that's our conclusion here. Is for the long run behavior, all that matters is the leading term. Short run behavior, the other stuff matters. Okay, so let's formalize that. The long run behavior of a polynomial is the same as the long run behavior of its leading term. And there's only 4 options for a polynomial. So for this section, there's only 4 options. In the next section, there's going to be some other things that can happen. So, and it's really nice because these 4 options look similar to things that we've already done. Right? Doesn't this kind of look like an x squared? You don't have to write this part down. I just want to show you. What does this thing over here look like? Well, at the ends, it looks like a downwards parabola. Again, who knows what's happening in the middle? We're just talking about long run behavior. So like maybe put this in parentheses or maybe don't write it down at all. This third one looks like a cubic function at the ends. And this last one kind of looks like a negative cubic function at the ends. Doesn't matter what happens on the middle. We're just talking about long run behavior. So that's how we can find out which one is which. If our degree is even, it'll look like one of these two. Either going up at the ends or going down at both ends. If the degree is odd, well, then it's going to go in opposite directions. What determines whether it goes up or whether it goes down? The leading coefficient. If the leading coefficient is positive, it goes up. The leading coefficient's negative, it goes down. So all you really need to remember is these 4 situations. Is it either a positive or minus x squared situation or a positive or minus x cubed situation? And again, notice if the leading coefficient's positive, then it goes up to the right. If the leading coefficient's negative, it goes down to the right. These are our 4 situations. So try to use these. Try to pause the video and see if we can get these pictures for example 2 by hand. So to do that, we just look at the leading term. We need the degree and the leading coefficient. There's our degree here, even or odd. The degree is 3, so it's odd. And our leading coefficient is positive. So it should look like a positive cubic function for the end behavior. It should go up to the right. Who knows what's going on in the middle? And it should go down to the left. And that's exactly what happened, right? That's exactly what we got from the graph. The next one in B, this is our leading term. It's going to be an even degree. And it's going to be a negative leading coefficient. So it should behave like negative x squared. Should go down to the left and down to the right. And that's exactly what we got. And again, to clarify, this boxed answer is the long run behavior. The pictures are just helpful to get us there. All right, this is an odd and negative leading coefficient. This is x to the first power. odd degree, negative coefficient, we can see this picture happen. All right, and all of these have the same leading coefficient. An even degree and a positive leading coefficient means all of these will look like this, which is exactly what we found. So that's how we can find long-run behavior. Let's use this to answer one more example, and then we'll be done with this video. So what can we determine about the long-run behavior and the degree of the equation for the polynomial graphed here? Well, what situation do we have for long-run behavior? It's going up to the right, and it's going down all the way to the left. For long-run behavior, we don't care about the middle part. We only care about what's outside of the circle here. What case is that? What situation is that? It's one that looks kind of like a positive cubic. We know that it must have a positive leading coefficient and odd degree. And it looks like a cubic function, but it actually might not be a cubic function. It looks like one, but it could be a fifth degree polynomial actually. All right. So we know the long run behavior. We mentioned what we know about the degree. I drew the picture for the long run behavior. So let's actually write it out. As we go all the way to the right, the function goes all the way up. As we go all the way to the left, the function goes all the way down. So notice the words I'm saying, they really do kind of match with what I'm writing. The math means what I'm saying. As x goes to positive infinity, that means as we go all the way to the right. So let me know if you have any questions. This is long run behavior, maybe the most, I'm not going to say it's the most important, but it's an important section of this section, an important subsection, if you will. Let's check in with October. How's she doing? Still blinding the camera with her radiance. Have a good day. Bye-bye.